This is Unit 5, Lesson 3, Part 3, the first derivative test. This part of the lesson is going to be a series of examples using the first derivative test to find relative extrema and intervals of increasing and decreasing. Okay, example 5. For each statement below, sketch a function that represents the results of the first derivative test for a continuous function y equals f of x with a critical number at c. So what you're supposed to do in each example is use the given information to sketch the graph. So I'm not going to go through and do each one of these separately. What I'm going to do is I'm going to have you pause the video and draw each of these and then check your answer. Now I just want to recommend or just caution you, your graph does not have to look exactly like mine. It just has to have the same type of features in the same critical area near C that is given in the description. So if your graph doesn't look exactly like mine, that doesn't necessarily mean that yours is incorrect. If you're unsure, you can show me in class tomorrow. So at this point, go ahead and pause the video. Okay, so there is an example of a graph for each of the situations for number 5. All right, number 6. Find the exact values of any relative extrema of the function g of x equals 1/2 x minus sine x on the interval from 0 to 2 pi. Justify your answer. So what we're going to do first, of course, is take the derivative. So g prime of x is going to equal 1/2 minus cosine x. Then we're going to set that equal to 0. So we get cosine x equals 1/2. And in our interval 0 to 2 pi, we have the first quadrant, which is pi over 3, and the fourth quadrant, which is 5 pi over 3, where cosine is positive and has a value of 1/2. So we're going to make our sign chart from this. Actually, I don't need arrows on the end. I just need endpoints. So here's 0, here's 2 pi. So we're going to have one critical number at pi over 3, another one at 5 pi over 3. And here is my sign of f prime. And here is my direction of f. And so I am going to use x equals pi over 6. And in between those two, I'll use, can use pi. And then between 5 pi over 3 and 2 pi is 11 pi over 6. Okay, now my signs. When you put pi over 6 in the derivative, you're going to get a negative sign. So that means that f is decreasing. And then, of course, we have our 0. And then when you put pi, you're going to get a positive number because you have minus -1. So you have a positive number, so that means f is increasing again. And then it comes to its next 0. And then at 11 pi over 6, you have the same situation. 1/2 is smaller than square root of 3 over 2. So this will be negative, so the graph will go down again. Okay, so what we can say then is that g of x has a relative min on 0, whoops, that should be a 0, 0 to 2 pi at x equals pi over 3. Since g prime of x is less than 0. And so that point is going to be pi over 3, comma, and when you substitute pi over 3 and you get pi over 6 minus square root of 3 over 2. And you can just leave your answer like that. And then g of x has a relative max on our interval, because obviously this is going to be a function at beyond 2 pi. You're going to have repeated relative minimums and maximums at 5 pi over 3. Oops, I should put x equals. Since g prime of x is greater than 0, and my point is going to be 5 pi over 3, and you get almost the same y value, you'll get a plus. So then you'll have, 5 pi over 3, 5 pi over 6 minus or plus square root of 3 over 2, because you have sine there, and sine's negative in the 4th quadrant. Okay, so there's the answer for number 6. And then we have a couple more to do here. So I am going to do just one of the 3 on the back, and you guys can do the other 2. So I'm going to leave you to do numbers 7 and 8, and I'll post the answers here. And then I will do number 9. So pause the video and do number 7 and 8. Okay, so here are the answers for 7 and 8. And I realized on writing the answer for number 7 that I did a poor job of my justification in number 6. I actually put why you would have an interval of increasing and decreasing instead of a relative min or max. So I want to go back real quick and fix that, and I apologize for that. This is not going to be because the derivative is 0 or the derivative is positive, or I'm sorry, less than 0. You want to put here, the reason for this is that g prime of x, y of a relative min, changes from negative to positive. Okay, because it's going down to have a relative min, and then it has a positive slope. And same with y, you have a relative max, because g prime of x changes from positive to negative. And I apologize for that. I was just writing down what I had on my paper, and I realized I wasn't really listening to what I was saying, and I wrote the wrong thing. Okay? Okay, and then finally, the last one. Given g of x equals x squared minus 3 over x minus 2, find the intervals of increasing and decreasing, and then find the x coordinates of the extrema. So this covers everything that we've been doing. So first thing we're going to do is find g prime of x, and we're going to have to use the quotient rule. So g prime of x is going to equal 2x times x minus 2 minus x squared minus 3 times 1 all over x minus 2 squared. Just to make a little note here, you want to remember x cannot equal 2. Okay, now we're going to set this equal to 0. And of course x, well, let me simplify that first before I get carried away here. So we have g prime of x is going to be 2x squared. So that gives me an x squared minus 4x, and then I have a plus 3, and that's all over x minus 2 squared, and that's going to equal 0. So of course x cannot equal 2, we already knew that, but that's not in the domain anyway, but we do have to check on either side of it. And then when we factor the top, that factors into, let me just do it here, x minus 3 times x minus 1 equals 0. So my other 2 critical numbers are going to be 3 and 1. Okay, and then I'm going to do my sign chart, which I'll do up here. And so we have they're all positive, so we have our 1, we have our 2, and we have our 3. We want to use the 2 just to see what's happening on either side of that, where we're coming from. So I'm going to put like a vertical asymptote there. Okay, so then here's my sine of f prime. Here's my direction of f. So I'm going to use x equals 0, x equals 1.5, x equals 2.5, and x equals 4. Just to see if there's any change, if the graph jumps, is why we need those other points in there. Okay, so when I put 0 in the derivative, I get a positive over a positive. The denominator is always going to be positive because it's squared. So this is going to be positive, which means the graph is increasing. If I put 1.5 in, the numerator is going to be negative, and of course the denominator is always positive. So it's negative, so it's headed towards negative infinity there. At 2.5, the numerator will also end up being negative, so the graph is still decreasing. And then on the other side of 3 at 4, when I put 4 in, I am going to get a positive numerator, and I already have a positive denominator, so it's positive. Okay, so here are my solutions. I can say it's increasing from negative infinity to 1, and also from 3 to infinity, since f prime of x is positive, greater than 0. Oh, actually, this is g, not f. I'll make sure I use the right function notation. And it's decreasing from, and you can just, since it's going to be you have to divide that interval up because the asymptote's in the middle of it, and that's not part of the domain. And our reasoning is g prime of x is less than 0. And then, of course, we have a, this is part A, then part B, or this is part I, this is II. We have a relative max at x equals 0. I'm sorry, x equals 1, right here. And then we have a relative min at x equals 3. Okay, so we'll go over this in more detail in class tomorrow. And if you have any questions, I'll answer them then.